All right, so just the quick overview of what an execution plan is. If you saw our implicit conversions episode that we did a couple months back now, you might recognize some of these queries and some of the plans. So this is an example. If we highlight this query, we turn on actual execution plans up here, which we use with the Control M key or this button on the toolbar, and then we can run the query. We see our results, but we get another tab here that shows the execution plans. And this first one took 100% of the overall cost, and the second one took 0%. So that's saying the second one is a heck of a lot faster than the first one. And you can see things about here's an index scan, here's a key lookup, nested loops, all that kind of stuff that goes into providing the results from that query. Now, we're not going to go into a lot of detail on this, but you've probably seen, if you've done anything with performance tuning, you've been able to go in and see execution plans like this. Now, one step further you can go is you can, from an execution plan, you can look at the XML, and there's a whole lot more information here behind what goes into that plan that's not being shown. But unless you're really into reading XML, and digging through all of this, this is probably not the most optimal way to go about analyzing your plan. So in Database Health Monitor, we collect execution plans in a lot of different locations, a lot of different places. One of them we have is Active Query CPU History. This is one of the many tables that we have in the DB Health History database where plans are kept. I have a query here. If we run this, it's going to look and see, okay, what are the high CPU queries that have been run in the last 10 hours? You could go change that. But we have one column we have here is the show plan XML, or the query plan XML. You can click on that and get access directly to that by poking around in the Database Health Monitor. And this shows you the plan, the same as it would have looked had you run it through SQL Server Management Studio with an execution plan turned on. Through here, you can scroll through and say, okay, well, here's 96%. That's probably most of it. Then we go down to this big chunk and squint our eyes and scroll around until we find, oh, look at that, 43% there, 8%. That's where all the work's being done in those bigger items there. Looking at this is what I've done for almost 35 years. And well, maybe not that long, because in the beginning, we didn't actually have the visual execution plans like this. They were text-based. But this is the way we've analyzed it for a long time. And I finally got a little bit, fed up with trying to have to explain some of these things and go through and say, well, here's the problem and here's this or that. So what we did is we built into Database Health Monitor some different ways to look at this. So let's take a look at that now. And what we've got, a couple things that we're going to take a look at here. One, we have just plain old Database Health Monitor application. There's a lot to it there. But we also have our query loading ramp, which is a tool that was released in 2026 that allows you to run specific loads against your SQL Server. I'm going to run this load right now. It's got, as we look at this, there's about 6 or 8 queries up here that are all specified. We can look at them that are doing a number of different things. Some of them are designed with some really poor SQL in order to be able to show some bad execution plans. So what we're going to do is we're going to run this load test. 200 sessions, we're going to ramp up time of 1 minute, and a run time, let's go for 2 minutes, a total of 3 minutes here, and we're going to run that load. So we're just going to let that run in the background, sort of like when you watch the cooking show and they just put the food in the oven. We're going to come back later and see what it looks like when it's done. So while that's running, what we're going to do is go look at a couple other areas. First off, in Database Health Monitor, there's a number of different areas that we can look at to find what's going on with different queries. If we go to like blocking by hour, we have here a chart showing, oh yeah, here's the busy times of the day, Monday through Thursdays it looks like, and there's a lot of blocking going on. Well, what we can do is drill down on one of those specific times. Let's look at this one here, 83% on Sunday. That's an odd time for it. And we can see, here's the query that was running. It was stuck on a wait for delay. And if we look at the plan analysis, here's our Database Health Monitor interpretation of the execution plan. What we've got here, it's taken the statement and broken it down. Instead of having to scroll through all the different parts of the plan in Management Studio, we can quickly see that this one here, select count from that, that's where 100% of the work's being done. If we want to jump right to that, we can click that query. We jump right to select count star from, yep, it's doing a table scan in order to get that. And that's something where there are a number of things that we could do to probably optimize that, like maybe have proper index on it. It says table scan. A full scan reads every row in the index or table. For large tables, it's expensive. Consider a selective index. If nearly all the rows are returned, scan may be intentional. So there's a lot of description in here, and it gives you a rating too overall. Like this query, or it says the plan for this query is given a score of B on an A through F grading scale. Now, with that, we also have, if you take a look at this and there's something that you don't know what it means, like stream aggregate. Oh, what does that really mean? Well, at the bottom, we have this operators and concept glossary where we can go down and find stream aggregate. Well, that groups and aggregates on pre-sorted rows. Sum, count, group by, very efficient, processes rows one at a time without a hash table. Okay, the stream aggregate in this case is probably what's being used for the count star. And just a description of what all this other stuff is in the query. Let's go look at some other queries, and we'll come back to that in just a moment and see some other information there. So if we go back to the blocking by hour, and let's look at something that's blocking in the last hour. There's a different one. And this is a server I've got set up with a specific blocking test. Yeah, this is the same query we're seeing here. Okay, so let's go and look at, instead of blocking, let's go and look at our long-running queries. So here we have long-running queries. We can go to pick one of these hours that has a lot of long-running queries in it, or maybe even one with less. Let's go look at this, just the last hour. What have we seen? There's 8%. There are, yeah, a couple dozen queries here. But if we look at these, we can go click on the query and then go click on plan analysis here, and it brings up the plan analysis. Now, that's the same one we looked at. Let's go over here and look at the queries and see if we can find. Okay, because this is the test server, we're seeing a whole lot of them that are all the same thing. Let's go look at a different point in time and see if we can find something different. Okay, here's a different. Double click on the query, plan analysis. Actual execution plan, this one is giving us a grade of F on a scale of A through F. It's doing one thing, it's this one query. Select from login history, cross-apply this, cross-apply that, where this. And this is one that I specifically wrote to use some of the things that we commonly see when we're doing performance tuning that people do that causes problems. So let's look at this one query. What is going on with it that's taking the time? Well, there's a stream aggregate, there's a clustered index scan. The stream aggregate has 2.6 million rows that it's analyzing. The index spool has 13 million rows. Sort has 14 million rows. So there's a lot of rows being processed here. But what are the things that are causing problems? And we look here and we can see some of these that are highlighted in pink versus kind of the, I don't know, yellowish color here. So things that you need to fix, these are the things that you should fix first if you can. Nested loops, high inner side execution count. Well, why are these running so many times? When we look at things like how many times things are being executed, well, cross apply, that's infamous for taking the results from one query set and passing it through to another query and running that subquery n times, where n is the number of rows in the original query. Okay. Implicit type conversions. Okay. Varchar 10 on login date. Well, let's look at that. There's right here, this convert varchar 10 on login date. This is something that we actually saw in a real performance tuning engagement where they were taking a actual date variable, converting it to a varchar 10 formatted in a specific syntax to be able to compare month / day and out to a specific number of characters for the month, for the date comparison there. Really inefficient way to do it. And that's why I put it in this query, was to show it in the plan. So this is really quickly showing what's bad. So here's the other side of the varchar 10 convert. Convert implicit. Now that's one of those that we did a whole podcast episode talking about those. And that's on transaction date. And where is that? That would be probably just this one that's happening down here. And then another implicit convert, functions applied to a column in the predicate. Okay, what is the predicate? The predicate is the where clause. So functions applied in the where clause, leading wildcards and the like in the where clause. Let's see what those are and why those are bad. Well, here's a function. So here's one where clause. And in there, the user email comparison is probably okay, but the char index on user in email, it's trying to find the offset to where the @ sign is in the email. And it's trying to find where one of them's bigger than the other for some reason. Well, in that case, the only way it can do this is to call that char index function in order to be able to scan through every single user email in that table to be able to do that analysis. And to do the comparison where that is greater than the other one, it also has to scan through every single row in the other table in order to perform those char indexes. Functions in the where clause are one of those things we typically refer to as code smells. And we did a podcast, I think, earlier this year or last year where we talked about functions in the where clause and kind of how big of a problem that can be. Let's see what else we've got down here. Leading wildcards with like predicates. Okay, what does that mean? Right here, where user email is like %7%. We're trying to find any user who has a 7 somewhere in their email address. Okay, why? I don't know. That's the thing. When we look at queries, we don't always see the why behind it. We just see what people are trying to do. The reason that this is inefficient is because when there's a wildcard at the beginning of a like clause on the search, that makes it so it has to do a full index or a full table scan. It makes it so that index seeks can't be used, because the only way to determine if there's a 7 anywhere in it, it can't use the index structure to get there quickly. It can use an index, but it has to scan every single row in the index to find that. Or it might have to do a full table scan depending on what indexes are available. So this is a really inefficient way of to do things. And when I see things like that, I always try and ask people a question of, well, why were you doing this? And is there some way we could do it differently in order to be able to make that query run faster or more efficiently? Let's see, we got a bunch of other stuff, blocking operators, tempdb pressure, high risk, active spills detected. Okay, that means there is a whole bunch going on that's dumping into tempdb. In this case, it's almost 2 gigs, 1.8 gigs of that was granted, but it wanted just over 4 gigs. So if there's things that could be done to make this query more efficient and filter stuff out earlier, it's going to help prevent so much use of tempdb. TempDB is that one shared resource that is used across all databases on your SQL Server, and having extra pressure on it is going to get worse and worse when you have lots of other databases on your server competing for that TempDB space. So on that, we can see also there's index scans, execution order walkthrough. Well, this is showing kind of the order of what's happening. It's doing an index scan on login history. It's then computing a scalar, doing a hash aggregate, parallelism, and all the way down. And it shows how many rows are being hit all the way going through here. So to be able to look and see, well, how can we make this faster? Well, you can look at what are the places where there's lots of rows being used and figure out, well, how can we filter those or reduce the overall load there. So that was quite a dive into this one single query here on the execution plan. But let's take a look. Remember earlier we started that load test. Let's go back to those load test results and see what that looks like now that it's finished. So this load test ran 200 sessions. It ran it for 3 minutes. It completed 1,500 queries. There were some errors. There was some blocking. Okay, that's all expected. This chart down at the bottom is showing the query latency, or how long it's really taking each query to respond out of the 7 queries that are being run there. And we can go look at the results. which we'll cover in another session. But right now, what I want to look at is plans. We're on execution plans. So let's look at the peak plans. So at the highest CPU load that this load test was running, these were the plans that were captured in memory that were actively running queries at that point in time. So if we scroll down, we can see, okay, well, update test table 1, it's doing that. Update test table 1. Oh yeah, there's a lot going on. There's probably a lot of blocking going on that because they're all doing the same update as there as well. But if we double click on one of these, we can look at the plan, and this plan has been given a score of B on an A through F scale, gradient scale. It's only doing one thing. Well, it's doing a table scan. So if there was some way that we could see, there's a where, if we could have the right index in order to be able to quickly return the rows that are needed for updating here, this one could be sped up quite a bit. A big 39% of the plan is being used to find what rows need to be deleted, and then 59% of the plan is being used to actually delete them. So we might be able to trim close to 40% of the overall cost of this query by adding an index that is the right place for that to go find based off of an ID equaling a specific value. Okay, so let's take a look at where else we can see these. In Database Health Monitor, we also have another tool called the Performance Viewer, which I've had running in the background here. Oh, and just a hint, if you're in Database Health Monitor and you want to run either the SQL Performance Monitor, which I just showed, or the Query Loading Ramp, which I just showed, or our Plan Viewer, you can access them here from the Tools menu. But let's go and take a look at the actual Performance Viewer. This has been running, tracking, monitoring for the last bit since before I even started the recording of this podcast episode. And what it's doing is it's capturing information here on blocking queries, long-running queries, high CPU queries. Those are kind of the areas that we can find plans on. And let's see if we click on some of these, if we can actually see the plan. View execution plan, we can see that this is one we already looked at before. One of the first ones we looked at that we found in a different area. But if we go and look at things like high CPU, well, what have we got here? Some of these, not all of them necessarily have the execution plan available here, but if they do, we can look at it. Here's one, view execution plan. This is one of those queries out of Database Health Monitor that's purging and cleaning up some data as the query runs. And we can see that this is given a score of F. And trust me, I've been working to improve this one. So it used to be worse. I don't know what worse than F is, but it used to be worse. So we're looking here, 44.6% is being taken on this one thing. And this is where we're collapsing or rolling up data over time, like beyond a certain number of days. So a lot of the work there is being done on an index scan. We're seeing stuff like functions in the where clause, which we know are bad. We looked at that earlier. Index scan, sorting, blocking operators. Yeah, just kind of an overview of the whole thing of what's going on. And keep in mind, at the end of this report, we also have, like I showed earlier, this is a long one. There's a lot of queries in here. Oh, here it's finding there's some statistics out of date as well. And maybe updating these statistics might help this query run faster. And then, of course, we have the glossary at the end, which tells us what all these things that are covered here are. And I'm just looking at where else we have this. Yeah, we're working on getting this into more and more places in Database Health Monitor. So you can just quickly click through, and hopefully one day, wherever you can view a query, you can go and view the plan as quick as that. So execution plans don't have to be hard. Hopefully what we've shown here with the execution plan viewer that we've built into Database Health Monitor will make it easier than the old way of doing it by either browsing the XML or clicking around and dragging the plan in Management Studio. Yeah, in the time since we added this, I've already used it on several customer environments and been able to find very quickly where some performance issues were that needed attention. Thanks for watching. I'm Steve, and I hope you've enjoyed this video. If you like it, please click the thumbs up icon. And if you want to subscribe, click subscribe to our channel and click the bell icon to get notified when we have new videos. All right, have a great day.